Welcome everyone. In this video, we are going to briefly learn about the decision tree created for the purpose of path exploration. In the previous video, we looked at the simulation of how the Pioneer 3DX robot used in the path exploration. Link to the previous video is available in the below video description. This is the decision tree created by our machine learning algorithm using the dataset that we supplied during the training process. Decision tree algorithm is one of the machine learning techniques that uses decision tree to make predictions. As you can see from this image, our algorithm automatically builds a tree-like model of decisions to help navigate our robot inside the maze. The algorithm uses our training data set by recursively splitting the data into subsets based on the most significant feature at each node of the tree. Root node is at depth level 0. These two decision nodes are at depth level 1. These four decision nodes are at depth level 2, and so on. At the beginning of our decision tree, we have our root node. If I zoom in, you can see we have four different lines with various information. In the first line, we have right proximity data less than equal to 0.355. This is a comparison check of the input sensor value coming from our Pioneer 3DX robot. If the condition is met, then we move from depth level 0 to depth level 1 by taking the left branch. If the condition is not met, then we take the right branch. We repeat this process to proceed below depth levels until we reach the leaf node to make the final prediction of which direction to move our robot. In the second line, we have information about a variable called Gini, G-I-N-I. Its value ranges from 0 to 1. If it is 0, that means we have a pure data set, and 1 indicates we have impure data set. If it is a pure data set, that means we have samples belonging to only one class, which is not ideal. We need samples equally split between all classes. In our case, we do have the value of 0.515, which shows we have a sufficient representative of samples from each class. One important thing to note here is that this value is very specific to this particular node, and it is not indicative of the entire data set. In the third line, we have information about the total number of subset of samples that the decision tree algorithm used to create this node. In this case, a total of 368 samples were used, out of which you can see how many samples were taken from each class in the fourth line using the variable called value. It is 14 for first class, 139 for the second class, and 215 for the third class. If I zoom out, you can see the decision tree is color coded. Each color representing a class, and also if you observe closely, it has different transparency level based on the purity of the class. The colors that are light indicates that our data samples are impure, and the colors that are brighter indicates that our data samples are pure in those specific nodes. The decision tree may not look the same for you, and it will be different each time you run this program. I hope this video was helpful. We'll meet you back in the next video.